Hello everyone, and welcome to my presentation, Data Mining in You, Exploring, Analyzing, and Presenting Unique Info Patterns in the Age of Big Data. The presentation is split into 3 sections, based on the learning objectives on the next slide. Let's get started. Here are the 3 learning objectives for this presentation. When you're done reading and listening, you will have an understanding of data mining and knowledge discovery databases, awareness of how data mining can help libraries, and some knowledge of privacy issues that come with data mining. Part 1. What is data mining? To really understand what data mining is, you must first know that it is just one step in a larger information gathering process called Knowledge Discovery in Databases, or KDD. Gregory Piatetsky-Shapiro coined the term in the late 80s. Knowledge discovery is the process of automatically searching large volumes of data for patterns that can be considered knowledge about that certain field. KDD is data specifically culled from computer databases. Like data mining, the process has several variations. One shown here has 5 steps: selection, pre-processing, transformation, data mining, and interpretation/evaluation. But some variations are as simple as pre-processing, data mining, and result validation. The advancement of technology has let information professionals take advantage of all the different ways of organizing and retrieving information with digitization, e-resources, online analytics, data archiving, and much more. Data mining has actually been around since the 1940s, and it was used for credit scoring. But it didn't become widespread until the late 1980s and early 1990s. Data mining is technology that combines artificial intelligence, statistical analysis, knowledge acquisitions from expert systems, data visualization, machinery discovery, and pattern recognition to find unknown pieces of information from large databases. Shown here is one model for data mining, and as you can see, it looks very similar to the process for KDD. If KDD is the overall process of discovering useful knowledge from data, data mining is the application of a specific algorithm or algorithms for extracting patterns of data. Alright, let's get down to data mining. The first step would be to determine the problem and area of focus. This could come from a specific problem in the library or a general area requiring exploration and decision making. The second step would be to decide to use undirected or direct data mining. Direct data mining is problem focused. An example would be if budget cuts have reduced your staff time for contacting patrons about late material. The question would be, is there a way to predict the chance patrons will return the material once it's a week late in order to prioritize your calling list? Undirected data mining is used when the library manager wants a better idea of a general topic area. One possible area of focus could be how are different departments and types of patrons using e-journals? Because undirected data mining uses many tools repeatedly to locate available patterns, usually invalid patterns are more probable of being found, or an overwhelming number of patterns may be produced that need to be explored. So this is only a good technique to apply when using well collected or clean data with a strong data warehouse. The third step is to identify appropriate data sources. This requires low-level transactional information that is non-aggregated. and you must choose whether to use internal or external data sources. Your next step is to create a data warehouse. It's usually a database that's used as a repository to store information uploaded from operational systems. This warehouse must not contain publicly identifiable information. To create the warehouse, librarians write queries to extract the data from identified sources, combine this data with using common fields, clean data, and then they write the resulting records into either a flat file or a relational database designed specifically for analysis. Once this procedure has been tested, it can be automated to pull data from the operating system into the data warehouse on a regular basis. It will be consistent data model regardless of data source, and it will make sense to the user. Another term for warehousing is pre-processing. Before the actual data mining process, where an algorithm is used on the collected data, you must choose that data wisely. Your warehouse must be large enough to be able to discover patterns, but concise enough to be mined within a reasonable amount of time. Actually, the pre-processing step is the longest step in the data mining process, and because of this time investment, it is better to have a narrowly defined topic or question. Data cleaning is part of the pre-processing or data warehousing. This includes the removal of noise, which is inaccurate or missing information. It also is for the removal of inconsistent data. This is a very important step, as you'll see later, because cleaning is the key to protecting your patron's identification. Now that I've given you a little bit of a background on data mining, I'm going to go through the entire process with you. We've talked a little about steps 1 through 4, which are where you establish your goal or question, select that data that is useful for that question, and then store it on a single flat file or relational database and filter out the erroneous or irrelevant data. But I haven't talked about the transformation of data yet, which is where you can reduce the number of data attributes or fields from your gathered data, and then create a format or Excel file that you can use your data mining algorithm on, which I'll go into a little bit later. Once you've used that algorithm, you can evaluate your results and tweak and filter it again, and create another document for your user that is much more understandable and user-friendly. And now we get down to the actual data mining process, which, as I mentioned before, uses algorithms. And there are many different algorithms you can use, and there are no established guidelines to assist in choosing the correct algorithm to apply, but each algorithm tends to lend itself to a particular type of problem. The three most commonly used algorithms are decision trees, neural networks, and Bayesian networks. Decision trees are similar to flowcharts or a game of 20 questions, which the algorithm segments the customers into significant groups. Neural networks are processing elements that are trained to discover patterns by using a sample of data and then testing it against another set of data to validate the model. It is used for banking and financing. Bayesian networks are a little more complicated. They are directed oscillate graphs whose nodes represent random variables and their condition dependencies, as you can see by the picture on the right. There are a number of data mining software packages that provide access to different data mining tools and algorithms. Statistical packages like SAS and SPSS have data mining programs but are expensive. Open source data mining tools like Weka contain many of the same options but at a lower price, although they aren't as user-friendly. So using these certain data mining algorithms, we come to find different groupings or outcomes. The 6 basic ones being classification, regression, clustering, summarization, and dependency. Classification is the mapping or classifying of data into several predefined classes. For example, banks want established classes based on debt or income ratio. Regression is a learning function which maps data into real value prediction variables, comparing, for instance, electric bills to a predetermined norm for that same time period and observing deviations from that norm. Clustering maps data into several categorical classes or clusters in which classes may be determined from the data, which is unlike classification, in which classes are predefined. Summarization is generating a concise description of data. Basic examples of this would be techniques that include the mean standard deviation of a specific data element within the dataset. Dependency is basically developing a model that shows how variables are interrelated. An example is if someone buys diapers, they are also likely to buy beer. So with those tasks or groupings in mind, we must look back at our sample data and make sure that it's of good quality. And by that I mean it's accurate, that we won't have many outliers, that it's complete and robust, and that the sampling is biased towards our question at hand, and that the transformation is correct for that task. By that I mean the fields that we've chosen are correct for classification, regression, clustering, and so on. There are 2 types of results from data mining: predictions and descriptions. Predictions forecast the future values of your data elements, and they are usually applied to attempt to see the future financial losses or gains for a company. These questions are applied to regression mining tasks. Description results come from questions that try to discover interpretable patterns in data and are applied to classification, clustering, summarization, and dependency mining tasks. Alright, we're through the hard part. Now we're on to part 2. What can data mining do for me? Bibliomining is basically data mining for librarians. It is used for interpreting user access, by that I mean reading and research patterns from interactions and circulation data. It's used to identify rankings of web pages by analyzing the interconnections of a series of related pages. It can be used to improve the precision of search engines by examining textual content and user logs. It can recognize the intellectual structure of works by analyzing how authors are cited together, and it can look at surveys and focus groups to analyze what they want in the future, as well as budget and cost-benefit analysis. So those were some examples of how data mining could be used in any typical library. Here are some examples I found of less than typical libraries. One library has made a database that has taken conversations from 19th century novels and is mining these conversations for particular patterns in language. Similarly, in October 20th, 2011, Michael Whitmore, the director of the Folger Shakespeare Library, presented early results of a project that mined Shakespeare's first folio. Using software called Docuscope, Whitmore discovered evidence of variance with syntax and vocabulary among Shakespeare's comedies, historical plays, and tragedies. In particular, he found that Othello actually has more in common stylistically with the Bard's comedies. Part 3: The Dangers of Data Mining. Data mining has become a buzzword again because of recent events with Edward Snowden and the NSA surveillance scandal. Privacy is an important matter, and when data mining for libraries, we must take into very serious consideration by making sure patrons' identities are never revealed. The quote I added here is from Alan F. Weston, and it says, "Privacy is the claim of individuals, groups, or institutions to determine for themselves when, how, and to what extent information about them is communicated to others." For better or for worse, here are some of the ways people and organizations can find data about other people and organizations. So as I said before, cleaning is the main aspect in privacy with data mining. After gathering and extracting your data from disparate sources for your warehouse, you must clean the data before it's analyzed. And as I said, this includes the removal of noise and redundancies and inconsistent data. This also includes, and this is important, changing the patron's identifiers and IP address numbers. An IP address is a numerical label assigned to each device participating in a computer network. For us librarians, that means it's an individual number on a transaction log that tells us what pages a person has been retrieving and how often. These identification markers should be deleted once you are calling your information for your warehouse. And usually a time date stamp is put in place so you can still have an identifier for each piece of information. Data warehousing should create a database used for pattern making that absolutely cannot be used to recreate the original transactional records. With information privacy, there are two important ways in which the introduction of a new technology can raise privacy concerns. Number one, the technology used to collect information about an individual or group of individuals without the awareness or knowledge of the individual about whom the information is being collected. And number two, individuals are aware that information about them is being collected via certain technology, but have no say in how the information about them is being disclosed. In the case of data mining, the former is usually the case. Here are 4 reasons data mining is less private than a normal database. Number 1, patterns involving patron information are derived from the data implicitly versus the explicit nature of database information. The people being used for this, like I said, don't know they're being used. Number 2, the possible use of just one database from which to gather information on people as opposed to multiple databases. There's usually safety in numbers. Number 3, the public nature of much of the information being extracted versus the private nature usually found in normal databases. Number 4, the non-predictive aspect of the information being taken from data mining, i.e. a person is looking at your information, not just a computer. Well, here is my bibliography, and that was my presentation. I hope you enjoyed it. I'm sorry if it was a little dry, but that's just the nature of the beast. and I was just scratching the surface. There have been numerous books written on this subject, and I hope it wasn't too confusing, because I know I had to go through it relatively quickly. Thank you very much, and goodbye.